Hello.
Have you seen her?
Alright, so one of my friends has one of those great big digital LED signs on their property, which you see driving down highways and stuff like that. They do moving advertisements and shit like that. So anyway, this is the controller. The design of the sign is shit. I mean, like, water gets into it. We've already conformed this board with urethane, so this whole thing has been waterproofed, but we didn't waterproof the embedded PC, which is this little bad boy. It takes a proprietary power supply, which is pretty much PC standard. So before we can actually work on this thing, we need to make a power supply for it. Now, if you look here, most of you will recognize the Molex 12 5-volt and ground. So we are going to make one of these. So before we even work on this bad boy, we are going to take this old power supply for a external hard drive thingamajiggy, and we are going to modify it to have a Molex connector. So first things first, let's get the power supply. Let me find a Molex connector, and I'm supposed to be really easy on my hand right now because I buggered it up, but yeah, I need to fix this for him, so I'm going to try to do everything left-handed. So I'm going to go find a Molex connector. Give me a second. A Molex connector. Let's see. I have all sorts of power supplies kicking around here. Yeah, oh, there's one. Molex connector. Multimeter. Strippers. Not the kind of strippers that most guys want to see. And I think I need to find some heat shrink, so give me a sec. And we've got some heat shrink. Now the last part of the equation is a power cord. Alright, we got a power cord. So let's cut this wire. That's the first thing we want to do. We're about to vandalize this piece of electronic equipment, so where's my little cutters? I know my bench is a disaster. I'm not the cleanest person in the world, but whatever, I get stuff done. So I'm gonna cut that off. It's going in the garbage. Oh, it looks like it might be color coded with a standard PC color code. Wouldn't that be nice? Okay. Strip that carefully. Look at that, 3 wires. I'll bet ya, yellow's 12 volts, red is 5 volts, and white is ground if we're lucky. If that's the case, it's just a standard pinout. Alright, so, where do I put my strippers? There they are. So let's strip this one. Now, most of you are probably thinking, Sarah, did you check to see that this thing provides enough current to run the device? And yes, I did. 1.5 amps on the 5 and 12 volt bus should be enough. Okay, there we go. We got our wires ready. So let's plug this thing in and test to make sure that I'm not retarded. Okay, so there we go. Oh, what do you know? Oh, yeah, voltage. Ooh, the pinout might be Chinglish. There we go, 20 volts. Alright, red's 5 volts. Nope. Let's try this. So it looks like in this case, yellow might actually be our negative. another way that we can test this too. Let's find something 12 volt. This might just do it. Let's check that again. Yellow's negative. Red is plus 12. White is plus 5. Oh yeah. There we go. Okay, so there we go. Yellow's negative. Red is plus 12. White is plus 5. Alright, let's get some heat shrink going on here. Here we go, heat shrink tubing. Need some scissors. Turn those two there. I need one big piece of heat shrink. Alright, let's fire up the old soldering station. Boop. Actually, you know what? Before I work with this, I need to change the tip, which I'm going to have to change it back when I go to actually work on the SMD. But out comes the bucket of bits. Alright, let's see here. I think I want that one. Alright, let's fire it up. Got my tip tinning stuff. I need a bigger workshop. I envy Big Clive. He's got that nice big Bristol board thing, you know? Alright, so I should probably unplug this and short it so that I don't, there we go, burn anything. Alright, so let's see here. I'm going to cut these, they're roughly the same length. We're going to take our large heat shrink, put that over that one there, and then we are going to strip back this one. Alright, that's going on there. Yeah, let's strip this one now. There we go. We are prepped. Alright, it smells like my soldering iron's almost at the right temperature now. Okay. There we go, put some tin on there. Okay, cool. Alright, so that's that. Now, we determine that yellow is our ground. So let's twist that yellow. Oh, this really hurts my hand. Ow. Okay, so I'm going to add a little bit of fluxy wire. And we are going to get the heavier solder. Oh, here we go. Pain in the name of science. Alright, so we've made a power adapter, and yeah, we've been able to get into the unit per se. I guess the next step that we need to do for this thing before we start pissing around with it is back up the hard drive, because the contents are quite valuable. So we're going to do two things first. Number one, we're going to go open it up. And I'm going to see that you guys can see my monitor. And everything else we're working with. So let me just move the camera here. I don't know. I'm a shitty cinematographer. There we go. Can you see? Yeah, okay, you can see everything. Okay, so first things first, let us connect the VGA port. We're just going to test the unit and see if it works. I'm going to switch this over to VGA. Alright, that should be in VGA mode now. Let's turn it on. Alright, it's booting up. Alright, cool. So our little embedded PC system here is booting. And the power fan doesn't actually work at the moment either. So that's something else we're going to have to... Or the CPU fan, sorry. We're going to have to, like, fix that because it's an embedded PC. It'll overheat. Alright, so this thing's booting. I'm going to kill it before it actually does anything. Alright. Let's, actually I'm going to leave the, camera where it is for the moment. Let's get the hard drive out of it. Okay. So this is using its laptop hard drive, but then it's also got this array of very, very fine little wires here, which I've already had to repair on a previous day, and I don't want to have to repair them again. So, get this off. This thing is very, very delicate and very, very expensive to replace. So, stupid Sarah cannot break it. Alright, so let's get this. This is actually the matrix interface board. I'm not too sure what the company calls it specifically, but what it does is it converts a VGA image to a Modbus or RS-485 type communication standard, which then shows up on the matrices, which then activates the pixels, which then shows the image. So, yeah, whatever. If any of you guys out there know signs better than I do, or, you know, display matrices or matrices, you know, feel free to correct me in the comment section, because I am definitely no expert. Alright, so here's the delicate part. Now there's the hard drive. How big is this little guy? Oh good, it's only 20 gigabytes. Fuck yeah. So the data on this hard drive is very, very, very hard to replace. And very, 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 very expensive. That's why I'm going to make a disk image. So you guys actually get to see me rock some Linux today. Here we go. We got the hard drive out. The hard drive's out. Alright, so now, carefully, I'm going to place this in here. And put that on Mitch's desk. Okay, so, I'm going to need my keyboard and mouse. Now, the next part is connecting this to a hard drive toaster. So I'm going to spin this around. There you go. Whoop. Alright. So let's connect this to the toaster. And we're going to fire it up. Now this toaster is actually connected to this storage server right here. So now, let's rock some Linux. I'm going to kill some lights so that you guys can see my screen better. I'm recording in 1080p, so I really, really hope that you guys can see this. There we go. No, it looks like it's over brightening because I'm using a shitty camera. I really need to get a new camera. That's coming hopefully at Christmas. Alright, so I'm going to open PuTTY. I'm going to log into my server. And we're going to start a disk image. Okay, so first things first, let's find that hard drive. So, let's see here. It's either going to be... I think it's going to be SDB. I'm not seeing it yet. Yeah, so it's definitely not that one. It should be SDB. Might just be taking a minute to load. Actually, it looks like it might be SDAA. There it is. Okay, so it's SDAA. Alright, that's kind of weird. I've never seen double letters on it. It's kind of strange. Alright, so let's exit this. Now I'm going to go to my temp directory. There we go. Alright, now we're going to DD. Okay, so DD input file equals /dev/SDAA output file equals sign underscore backup .img. There we go. Now we just let it sit for a while. Sit and stew as it images the entire friggin' hard drive. Alright, so as soon as that's done, we'll put the hard drive back in the unit and we'll boot it up and see what the hell's wrong with it. Alright, cool. So, that's part 2. First part was making power supply for the unit. Part 2, of course, is imaging the hard drive. And part 3 will be repairing or troubleshooting the unit and repairing it if needed. Alright, thanks.